Everyone. I'm also from Seattle, and I actually live very near my office, which is I can walk to the office. That's really nice.
That's awesome. I feel like that's like the dream is that you're able to, your commute is walking or, riding a few blocks on your bike. And I'm in Oakland, so I'm the sole Bay Area resident of this tech talk. I feel like usually it's reversed. Usually it's like folks in the Bay Area. So this is cool having folks
Yeah,
outside
exactly.
of the Bay Area.
We are taking over. That's right.
Awesome. Okay, I think we might be all set. Let me just check LinkedIn. Hi, if you're joining us from YouTube, happy to have you. Okay, I think everything looks good. I'm just sending Denny the links so we can help answer questions.
Well, we have people from all over the world. We have from Berlin, from India. Hi, everyone.
North Sac, cool. North Sacramento, I think, on YouTube.
Yeah, I think so. At least I would certainly hope so.
I went to school at Chico State, so that was my first guess, North Sac. All right, well, I think everything looks good, and let's get into it. I think without further delay, let's kick things off. Let's get started.
Sounds good.
Awesome. So let me just share my screen real quick. A few slides to get us started. All right. So welcome everyone. Thanks for joining us. We have another Tech Talk. This is actually our second Tech Talk of the week, which is pretty cool. Today we have Phan and Eric from T-Mobile team here, and they're going to be talking about scaling XGBoost for thousands of features with Databricks. So this Tech Talk is recorded and it'll be available immediately after on YouTube. So I'll drop the link after I'm done with my slides. So if you'd like to revisit the session at a later date, feel free. I'll also update the copy there too if there's any resource links that are mentioned throughout the presentation. So you'll have everything there after. And I'd like to invite everyone joining us on YouTube and LinkedIn to join our meetup. So this is the meetup group that we run all of our online Tech Talks. And if you join the group, you'll be notified of upcoming sessions. You'll be able to plan and save it on your calendar. I also put all of the recording links there too. So in case you'd like to revisit a session, we have a really awesome meetups and Tech Talks playlist on our YouTube channel. So all of the content is there for you to visit if you'd like to. So I think this might be, since it's our last Tech Talk before the 16th, which is next week, I wanted to give a shout out to our Boulder, Denver group. So the folks over there in Boulder, Denver area, they are running an online Tech Talk about Ray. And so I invite you to join that. I'll drop the link as well too. I know it's a regional event, but I figured since it's online, folks can join as they wish if the time suits you. And it sounds like a cool topic. And I think Jules Demji, a former teammate of ours, is hosting this talk, so it should be a good one. And also we have our annual conference coming up, so Data and AI Summit 2022. That's June 27th through the 30th, and really awesome. It's going to be a hybrid event, so if you'd like to join us online, more than welcome. And we're also going to be in person in San Francisco at Moscone Center. So I think for some of us, or at least for me and Denny, this is probably going to be our first in-person event in quite a while. So we're very excited. So hopefully you'd like to join us in person or online too. It's going to be lots of awesome tracks. I think like over 200 sessions, lots of amazing different events. We'll have a developer lounge with cool workshops and all that good stuff. And come hang out with people in the data and AI community. I'll drop the link to register too if you're interested in checking out the details. All right, without further ado, I'm going to pass it over to Phan and Eric.
All right. I'm going to share my screen. Go. Got our slides.
Looks good.
All right. Hello, everyone, and thank you so much for joining us. Welcome to our talk, which we're calling How Do We Make Our XGBoost Model 300% Faster Using Spark? Or as you may have seen on the Meetup website, Scaling XGBoost for Thousands of Features with Databricks. My name is Eric. I'm a data scientist, and I'll be doing this talk today with Phan, who's a data engineer. We are both at T-Mobile on the T-Mobile Marketing Solutions team, and we're going to be talking about one of the projects that we worked on last year. Whoops. There we go. So to go over the agenda for today, first, we're going to talk about the business use case. So we're going to talk about why we did this particular project, what it was used for, and where that data ended up. Next, Phan's going to go over some PySpark best practices, some tips and tricks that he has found over the years. And finally, we're going to talk about XGBoost in particular, our project using XGBoost and how we scaled it and deployed it on the cloud using Azure Databricks. So as I mentioned, before we get started on XGBoost, I want to go over business use case, talk about why we did this particular project to begin with. So in order to talk about the project, as I mentioned, Phan and I are on the T-Mobile Marketing Solutions team. I'll talk a little bit about who we are and what we do. So T-Mobile Marketing Solutions is a company or a business within T-Mobile that leverages T-Mobile network data and third-party data from data partners to create B2B products that do targeted advertising, generate insights based on audiences, and does campaign measurement. One of our main products is called the Magenta marketing platform. That is what the project that we'll be discussing today got deployed to, and that's where the data ends up. So first I want to talk a little bit about the Magenta marketing platform. We ended up creating an age prediction model for the Magenta marketing platform. So what the Magenta marketing platform does is it allows marketers to target a specific group of devices based on a variety of criteria. For example, one of our main products or main features is we allow marketers to target devices based on the apps that they own on their device. So if you wanted to target devices, all the devices that had the Bank of America app, or if you wanted to target devices that had any of the video streaming apps, you could create a segment that includes just those devices. So one of the other main features that we have on this Magenta marketing platform is demographic ad targeting. So today we're going to talk about the age prediction model. So demographics in this case includes age, gender, income. This particular project is going to focus on the age prediction model. Phan and I worked on revamping this model last year because we acquired a new data set that came to us internally. This data set was a lot higher quality than the previous data set that we were using. So we were able to generate much more accurate predictions. Since this data set came to us internally and came to us through a particular product, the way the product was set up, we were dealing with age bins rather than age specifically. So this particular project was a classification problem. So we're trying to classify devices into age bins, for example, lower than 25, 35 to 55, etc. So as I mentioned, we recently acquired this new data set from one of our internal products. And one of the things you might be wondering is why don't we just use this data directly from our internal product and pump it directly into MMP? One of the reasons is that the deterministic data, as we call it, is very limited in scope. So the number of devices is much smaller. One of the reasons for that is because the way that we collect the data is from voluntary responses. So through our product, there's a set of questions that they go through when setting it up, and they can answer some demographic questions if they like, but only about half of customers actually answer those questions. So From there, we're dealing with about 50% customers. On top of that, this product is only deployed to a subset of devices and platforms. So in order to boost our scale and remedy this lack of scope, we are making predictions from our network data, the T-Mobile network data, which covers over 10 times more users and covers a broader array of devices and platforms. So how are these demographic insights used? So I mentioned we're making these predictions to try and determine which devices correspond to which age bin. So when a user creates a segment in the Magenta marketing platform, they can create a segment from a variety of means, one of which is app ownership. So if they were looking for a if they want to target everyone with the Bank of America app, for example, or Starbucks app, whatever it is, they can create that segment. We'll generate a list of devices that have those apps. And then automatically, when they create that segment, we will also generate a set of insights. And this is where the demographic modeling comes in. You can see a breakdown of different insight information, one of which is gender, one of which is age, income. There's device information, location information, etc. So as I mentioned before, the demographic insights are one of the main drivers and one of the main reasons for the success of Magenta Marketing Platform. So it's pretty important that we get this right. So revamping our age and gender model was very valuable to us as a company. All right, so now that we've gone over the Magenta Marketing Platform and why we decided to do this project, I'm going to pass it over to Phan, who's going to talk about PySpark best practices.
Thank you, Eric. Thanks a lot for introductions. So we know that, so I'm not a data scientist here in the team. I'm more like a data engineering, and especially I'm working a lot with Spark, and my main job is scaling Spark, PySpark to be specific, to scaling PySpark code and model into a bigger scale. The bigger scale here, we're talking about terabytes of data daily. We're talking about a lot of features, and the model here, it's just a big scale. You might already aware, maybe experience your own, that Spark is very easy to start with, very easy to write, but it's hard to config, it's hard to optimize, and it's hard to understand every detail inside. And especially when Spark community doesn't really have a very official tutorial for advanced development or big scale or deploy things to productions. People tend to do everything differently and just using some sample code from Spark documentations, which is a simple mistake can lead to some cryptic Spark error. As you might all experience your own, you can see some errors that you never understand why, what is that, and you just misleading and just searching around. So I really hope that some of the best practice today I'm talking about today will help you to avoid those mistakes and avoid some of the errors that you might have. The first thing I want to talk here is the it's the import. So you might have seen this one. It's very familiar that you import star. It's very easy to start with. You just import star from function. From function you import star, and you can import some specific functions like min, max, or average. So on one side, it's very easy to use. On the other side, it's going to cause some conflict between PySpark functions and Python built-in functions. So sometimes you want to use PySpark min-max, but you're going to end up using Python min-max, for example, or vice versa. So in order to avoid that problems, you want to use an alias when you import it. It sounds simple, but it's really going to save you a lot of time on debugging and figure out why you're having that exceptions that not related to importing or min-max at all. So strongly advised to import as an alias here. Again, you don't have to use F as an alias, but you can use anything. However, just try to try to standardize it in your org, so everyone using the same alias. That's gonna make your life much easier. The next one I would like to talk about is the Pandas. So it's totally understandable that if you use Panda for analyzing, it's you using Panda for years and visualizing, and you're familiar with all of the Pandas APIs and interface. That's totally understandable, especially as you come from data science background. However, Pandas does not scale. Everybody know that. So whenever you try to read from anything with Pandas or write Spark to Pandas, you literally only use the driver computations. You're wasting all of the workers' computations. In other words, even no matter how powerful your cluster is, you always can use the driver only if you convert everything to Pandas. So in order to avoid that, you can use the Pandas. You can use the Spark API probably, like using a read API. You can write using write API in any format you want, and you should use all of the transformation API that built-in transformation like with column and aggregation functions. And I'm not sure if you know that, but you can wrap all of your transformation into a function and use transform API to organize your code much easier, much cleaner. The third thing I would like to talk today about the best practices is UDF. So instead, I understand that many of you that coming to PySpark in order to to convert legacy Python code into PySpark adapted code. On one hand, wrapping everything into a function, UDF functions, it's easy and it's convenient because you don't have to unit test again. You don't have to think much about the logic inside the UDF functions again. But on the other hand, it's slow. UDF, it's well known as a bottleneck and slow and not fully optimized in any way. You're probably aware that under the hood of Spark, there's an optimizer called Catalyst. That Catalyst will not optimizing anything in your Python UDF at all. So not to mention that Python UDF is also sitting out of the Tungsten engine, computation engine, and it's processing one row at a time. So you might want to stay away from UDF as much as possible. One more thing that I observed during my experience here is when you keep thinking and writing your code, follow your thoughts, you tend to write everything at once, one line, and until you realize it's too long, you try to break down using the backslashes. It's okay to use backslashes and to break line, but I figure that there's a much better way to organize your code is using the parentheses. So you wrap everything in a parenthesis, in a pair of parentheses, and you can break to many lines that you want. You can break, you can indent it, you can spacing it for in any way you want, just to make it readable. As you can see here, I'm using with column, multiple with columns and multiple transformation, and I can have a nested transformation as well. I can just indent any way I want, just to make it cleaner and easier to read later. The last one I would like to talk about the best practice today is the JDBC connections. So on the left side, what you're seeing is the exact copy from Spark documentations. It's easy, very easy to start with, but just to remind you, this is just a POC. It's just an example of JDBC connections API of Spark. It doesn't meant to read the big scale of data. What it does, it actually send a query that you're having here, like select star from a table to JDBC, and there's not much of parallelism applied. I strongly suggest to use 4 more parameters here in production, and especially when you read with a big table of from the JDBC, using partition columns, lower bound, upper bound, and non-partitions. Essentially, these 4 parameters gonna break down your big query, your single query, into multiple queries that using between, limit, and offset. So let's say if your query is select star from a table, from table A, these 4 parameters gonna break down that one query into a smaller query like select star from A, between some numbers, depends on your partition column, and with some limit and offset, depends on the lower bound, upper bound, and non-partitions. So you're gonna have many other smaller queries like that, and all running in parallel. So you utilize all the workers to run your query all at the same time, and you're gonna have a much more throughput and much more speed. So there is much more optimization and best practices that we figure over the years, but those are the most important ones, and we think those can really improve your Spark code and model. And now let's go back to XGBoost story and how do we improve it? Back to Eric.
So in this part, we're going to talk about XGBoost in particular, and this project where we're predicting age from the data set. Before we get into XGBoost specifically, I want to talk a little bit about the data set that we're working with. So as I mentioned before, we wanted to make predictions using the T-Mobile network data because the scope of the data is much larger and covers a lot more devices. So we ended up creating about 15,000 features from a training set using this the user's network usage, and that was out of a total of about 40 billion possible features. So what I mean by that is the features that we used were all individual SNIs. If you're unfamiliar with SNI, an SNI is essentially a host name. For example, Amazon.com is an SNI. It also includes subdomains like aws.amazon.com, console.aws.amazon.com, etc. So they're, over the course of a month, when we take into account all of the SNIs used by customers in the T-Mobile ad program in a whole month, that turns out to about 40 billion SNIs per month. We ended up using about 15,000 features, which resulted in about 1 in every 2.5 million SNIs becoming features. So how do we get from 40 billion down to 15,000 SNIs? First thing we did was to filter out the least used SNIs. So 40 billion SNIs is a lot, but most of those SNIs were only used by a handful of our users. And so they wouldn't carry a lot of predictive power in our machine learning algorithm. So one way that we filtered these out was to create multiple thresholds to determine how much of these we wanted to filter out. For example, one of the thresholds we used was to filter out any SNI that wasn't used by at least 1% of our users. So we created 3 thresholds. One is 1%, 0.1%, and 0.01%. So if it wasn't used by at least that percentage of users, then we just disregarded it completely. Using those SNIs that we were left with, we aggregated usage based on age. So we aggregated on age bin, and then we calculated the normalized difference between one age bin and the average usage of all of the other age bins. So we ended up with an age bin, or sorry, a list of SNIs for each age bin, and then kind of join those all together to get the most valuable features. Next, we need to determine how many of these features we want to keep. So it's possible we could have used all, hundreds of thousands of features, but likely a lot of these features wouldn't really add a lot of accuracy to our model. So what we did here was, again, we created some thresholds starting at 5,000, going to 10,000, 15,000, etc., all the way up to 30,000, and then did a training and validation step using logistic regression to determine at what point adding more features no longer became useful. So we found that 15,000 about was the number of features where we had the highest accuracy, but adding more features after that didn't really increase the accuracy at all. And finally, our data set ended up being 60 million T-Mobile customers. So our final data set that we made our predictions on was 60 million rows and 15,000 columns. So now we're going to talk about XGBoost. One of the things I want to answer is why do we use XGBoost? Spark has a bunch of different built-in machine learning algorithms. XGBoost is not really one of them. So why do we end up using XGBoost? One of the reasons is that it's in general a top-of-the-line machine learning algorithm. It generally outperforms other tree-based models, other gradient-boosted models, random forest, etc. If you look at Kaggle competitions historically, XGBoost is one of the most popular and well-used machine learning algorithms by the top performers in Kaggle competitions. One of the reasons that XGBoost performs so well is because it has a built-in regularization feature, which regularizes the parameters as it trains. In our particular case, XGBoost added a 10% accuracy boost over all of the other methods that we tried. So we decided to stick with it because an extra 10% boost in accuracy is hard to ignore. So we went from about a 70% accuracy up to 80% accuracy just from switching to XGBoost. And that is over all of the other methods that we tried, which included all of the built-in Spark MLlib classification models. So other tree-based models, random forest, decision tree, gradient boosted decision tree that included support vector machine, logistic regression, naive Bayes, and some other ones. We tried a stacked ensemble method where we had 5 machine learning models, and then the predictions from those models fed into another model, which made the final predictions on age bins. There were a few other methods that we tried, one of which was to convert this classification problem into a regression problem by converting these age bins, translating them into actual ages, and then converting those ages back into age bins. So of all of these different methods that we tried, the maximum accuracy we saw from all those was about 70%. And switching to XGBoost produced an accuracy of about 80%. The only downside was that XGBoost in our case was very slow compared to the other models that we tried. So I'm going to pass it back to Phan, who's going to go over what we did to boost that speed of XGBoost. Back to you, Phan.
Thank you, Eric. So how it's slow? How much is slow? It's slow actually, and how long it's long, we never know. It's long and slow here. It's just a very subjective matter. But for me as a machine learning engineer, I'm saying 20 hours for engineering step. It's slow, and I'm sure that we can do something about it. And in fact, we did. We managed to nail it down from 20 hours to only 10 hours. The faster engineering here, that means it's more scalable. Let's say right now we have 15,000 features, and we have only 16 million of users. How about in next year, we're gonna grow up to double our subscribers, and we have more features we want to add into it. 2x faster, it's gonna be a huge improvement for engineering staff. Not only that, the XGBoost training now is great. It's improving from 3 hours to only 40 minutes. Training faster, that means you can tune your hyperparameters much easier. You can try with more iteration. You can try with more deeper tree, and you can try with many other different choices of yours. You don't have to wait 3 hours per train anymore. It's gonna be 4.5 times faster. And not to mention, you're gonna use less resources. Initially, we used 35 workers with 16 core each. Now we only use 10 workers, which is a lot of improvement in terms of resources. We ended up using less 3.5 times resources. Less resources, that means less costly, and it's gonna save you lots of money especially when you run your model more frequent. So how did we end up with, how did we achieve that result? So I separate here into two different steps. The first step here is the basic one related to the choice of interface and the choice of configurations. The first thing we want to do, the first decision we want to make is using either Scala XGBoost or Python XGBoost. So as you might already know, XGBoost community can read the Scala implementations for Spark. It's not from Spark community, but it's from XGBoost community, and this one is official. However, I understand that many of us coming from Python world, from the Python background, and we all familiar with PySpark interface. So it's very understandable if you're looking for the XGBoost Python wrapper. And there is one wrapper over there in the internet that you can use. It's not official supported from XGBoost community, but there's one. The downside of that wrapper is kind of out of date, and it doesn't support some of the important features like what you are seeing here. The default behavior of XGBoost is to kill the Spark context when there is something wrong with the training process. So you're gonna find this behavior, it's kind of annoying, especially when you are developing it, because who knows what could happen when you train your model. It could be memory issues, could be features issues, could be data issues, cluster issues, many issues could happen. But for whatever reason, when that error happened on the training process, your Spark cluster is gonna die. You have to restart it. You have to rerun the whole notebook again. So using Scala XGBoost gives you a capability of using all of the latest parameters, latest features, like the first one you see here, the kill Spark context on worker failure. You set it equal true, you can disable that behavior completely. You can reuse your Spark context as many times as you want. The other one I would like to talk here is the missing value. So XGBoost by default, not XGBoost for Spark, but XGBoost, normal XGBoost. The default behavior is treating 0 and missing as missing values. As you might already aware, all of the machine learning, Spark machine learning models, it took the input of those are the vectors. Some of them are vectors, some of them are dense vectors, some of them are sparse vector. But we're gonna have, if you use sparse vector, you're gonna have a lot of XGBoost will consider 0 as a missing values here, and we don't want that because that's a wrong behavior. That's a wrong assumptions. So you want to tell XGBoost specific that no, our 0 are not missing. So that's why you have to pass those parameters allow non-zero for missing equal true, and you pass a missing number is to some random number that never exists in your data. So that is some features. There are many other features that only come with Scala because they are updating quite frequent and very useful to use the latest features of Scala. The next thing you want to improve is the parallelisms. So you want to change the Spark configurations here. The Spark.task, the CPU equal with CPW, which is the terms of core per workers. Whenever you decide to use the spec of the cluster, a Databricks cluster, you always have to choose what kind of worker you want to use, what kind of driver you want to use. Driver and worker spec here always contain the number of cores and number of memories. So this CPW is the core per workers. So let's say if you choose a worker has a spec of 16 cores and 256 gigabyte of memory. So CPW is going to be 16 here. If in case you don't know, Spark.task the CPU will define the number of cores per task. So when you're saying task CPU is 16, that means every task in XGBoost gonna use all 16 cores for computations. Why is that? That's because XGBoost meant to use all of the cores per task to compute everything inside it. So we don't want to use only single CPU per task. That's gonna waste the other 15 cores. Not only that, you also have to configure your XGBoost using n thread to the same number of core per worker. You saying that you will essentially telling XGBoost to use all of the cores and telling Spark that also using all of the core for computations. It's really helpful, and people usually, it's very easy to miss this configuration, even though it's really powerful. One more thing you want to configure the XGBoost configuration is the tree method. By default, the tree method, it's exact. If your data set is bigger, it's automatically changed to approx. But when you deploy to production, you want to use his method instead. This his method essentially is gonna reusing some result without recalculations by caching some of the data in memory. That means it's gonna use much more memory, but it's gonna compute much faster, especially in the case you have many features and your data set is big, it's huge. It's also recommended to use in productions. The last thing you want to do is disable the Databricks Autoscaling. I have to really highlight here that Databricks Autoscaling, it's a great feature from Databricks. When it's going to save you a lot of money, Autoscaling is going to scaling your cluster up and down, scaling the number of workers up and down depends on your workload, depends on your transformation, depends how much compute you need. So that is going to save you tons of money, because when you don't use that much, you want it go automatically scale down. But in this particular use case with XGBoost, as I mentioned earlier, with Spark CPU and task CPUs, XGBoost is gonna use your entire cluster all the time. So we strongly suggest you to build a dedicated cluster only for XGBoost and disable the auto scaling, because XGBoost is gonna use the entire cluster anyway. So there's no point of scaling up and down here. It's just waste of time. And that is the three improvement on the basic configuration that you really want to try out. We're gonna go to more advanced and optimization next slide. In order to improve our XGBoost model here, we have to understand how the data is transformed before feeding to XGBoost. So this is the normal data set, very normal one that you might have on your own. The first step we want to do is to pivot it into columns. You turn your data into features. Remember that we're going to have 15,000 columns here like this and 60 million rows, which is a massive table. And after this step, you have to combine all of the features together and build the you build vectors. It could be a sparse vector, it could be a dense vector. So this is the whole normal process. And in order to this transformation, this is typical. Can you go to next slide?
Sorry, yeah, I think there was a disconnect there. I think we're back okay now, right?
Yeah, I think so. Thanks, Eric.
Okay. Yeah,
so
perfect.
In order to do that transformation, we usually have to do pivot and then the vector assembler like so. So the first step is pivoting and group by and then pivot, and then you to all the different columns, and you use vector assembler to assemble all of the columns together. Why do we have to do this? Because vector assembler take the input at all the columns. So essentially, you always have to transform your data in any kind of in any form. You have to transform your raw data into in terms of columns in order to make it as a vector. You can improve your pivot by passing the values. So Spark doesn't have to figure out what is the distinct value for pivoting anymore. However, we're talking about 15,000 columns here. That means when you pivot, you have to transform your data into 15,000 columns. And the only purpose of that transformation is just to build this vector. So in another word, you don't use those 15,000 columns for any other purpose. So why do we have to transform it to column and to only use it once? I figured that we can totally skip the pivot process and build the vector directly instead of going through a vector assembler. And as you can see here, it's 20 hours plus. So how do we do that? We can skip the vector assembler and build vectors from RDD directly, like so. Just to remind, just a gentle reminder here, when we're talking about RDD, we're talking about the unstructured schema, about the data structure that is schemaless. So instead of dealing with the column name, we have to use indexes now. So 0 is representing for user, 1 is representing for store, and 2 representing for amount. You want to group by, just like normal, you want to group by users because that is our key column here. And you're going through 2 map process to build a map and to build a vector. In this case, I build the dense vector, but you can use sparse vector. It should go in the same way. And after you transform it to dense vector, you convert it back to a data frame. Using here, I'm not using vector assembler at all. And I also don't use the pivot function because we don't need the columns anymore. We build the vectors directly. So that is how you should, with all of this transformation, you're gonna save a lot of time on computing because because now you skip the pivot step. You can skip a lot of overhead of computing overhead. So now with all of these changes, our feature engineering step is now only 10 hours. Those are all the changes and all of the optimization that we have done to make our XGBoost much faster as of today. Thank you for listening and for joining. We start taking a question now.
Perfect. So thank you very much. We actually had a bunch of questions pop up, so I'm actually trying to sort them through right now. But I think that I'll do some clarification questions, which I'll actually answer. So that way we just go through it. And then actually I'll ask you guys the tougher questions. So there was an initial question during the presentation, what's an SNI? And I said it was a subscriber network interface. Basically think of it as like the unique address for the device. So all the devices that are on T-Mobile network. So that the idea is it's a lot of information that Phan and Eric are currently going through right now. So pretty cool. So there was a couple of questions specifically about, for example, why specifically XGBoost Spark versus, for example, Spark DL XGBoost, right? That's the one which is the Spark deep learning. Why not use that, for example? Just curious if you had looked at that or just wasn't interested at the time because you had already had the code up and running with Spark XGBoost. Sorry, XGBoost Spark. I'm always saying that backwards.
Yeah, that's a good question. I guess the easiest answer is I hadn't heard of that one, so didn't occur to me. Didn't try it. We had gotten really good results from XGBoost 4J Spark, as mentioned, and decided to wrap it up and go from there. So we were operating on a certain timeline. We tried XGBoost and it performed really well and gave us good results. So we just kind of stopped and moved on from there. Yeah.
No, that's a great answer. No, you had a tight timeline, you had something up and running, so let's go do it. But to people who are wondering, that is correct. There actually is this concept of the Python-based or Spark deep learning-based XGBoost. And yeah, it's worthy of trying, absolutely. But I think the key context of today's session isn't so much whether you're going to go specifically use that, a version. It's more the fact that there's some really good knowledge here on how to optimize either way that's applicable to all, because all this advice, by the way, that Phan and Eric showcased, it's going to be super applicable to all of you, irrelevant of which methodology you're going to use. Because, for example, like when you're running in production, XGBoost is going to use all the resources, so it doesn't matter which version of it is. So yeah, turn off auto scaling, because you want to basically just let it utilize all the resources, as an example. There actually is another question which I'm going to pose to you guys as well, is that by any chance had you tried out HyperOpt to help with the hyperparameter tuning?
No. Just the param grid. We tried that, and the Spark pipeline to figure out hyperparameters. So in terms of hyperparameter tuning, we didn't. The only hyperparameters that we tuned were the max depth of the XGBoost trees, and the max number of iterations. So between those two, it was basically a simple grid search to figure out which ones performed best. And also we had to balance how long it took as well. As we mentioned, originally it was taking about 3 hours to train the XGBoost model. So it may have performed better with more deep trees or more iterations, but it didn't seem to be improving much beyond that. And it took a lot more time. So we decided to cut it. I think it was max depth of 40 and max iterations of 50. But to answer your question, no, we haven't tried that.
Cool. No, that's a perfectly cool answer. So just like, again, what Eric noted, the fact is what the processes they had built out already worked well, and with the tight timeline, they had to push it through, and it's already garnering them excellent results. So yeah, I'm pretty sure everybody's pretty happy with what they've done. And if you're looking for it, there's actually a great blog post by Sean Owen about how to not tune your models using HyperOpt. And so please take a look at it. It's actually an extremely good blog that explains actually how to use HyperOpt if you happen to want to go do it. So let me ask one more question, just because we're cutting pretty short on time. But I think this is probably directed to you, Phan, which is, did you investigate or how did you investigate or know that the method would be faster than vector assembly and pivot? When you were talking about the vector assembly and pivot aspect of things, did you just try a smaller data set? Like, how did you approach to figure that out?
Great questions. I technically had to do the try and error a lot. So I tried to see, to break down the whole notebook into a smaller step and try to use, because we're going to use the whole cluster, so it's easier to measure. And I try to measure every single step. So this transformation step, how long does it take? And the training, how long does it take? Even for training, I try with different parameters, just like Eric did with the grid params. I try with every single different depth and different iteration, just to see how slow, for whenever we change the hyperparameters, how slow it is. And I try to see for X transformation, because when our instinct when we want to scale something is we tend to increase and change the cluster spec. We add more workers, we add more cores, and we expect it to run faster. But that's not the case. That's not always the case. Sometimes when you increase the cluster, it doesn't really run faster. Like in our case, before, when we use pivoting and vector assembler, even though if we make it to 1,000 of workers, it doesn't really run faster than 50 workers. So what's the point of using more workers if the process is not gonna fast any faster, right? So what we figure out after we use the RD method to transform, we realize that it's scalable in a way that if we want it to run faster, we just need to add more cluster. So it's much more scalable, and that we also using the same method that we measure by adding more cluster and see if it's faster. and try to imagine on every single step, just to see if it's really run faster using pivoting and using RDD.
Perfect. Thanks very much, Phan. So, and for that awesome answer. Karen, at this point, I think it's, even though I realize there's some other questions, I think this is probably the right time for us to wrap it up, actually.
All right. Thanks so much, Denny. Thanks everyone for your questions. I did add the blog that Denny just mentioned, and I'll also put it in the event description since it's a good one. And so thank you so much, Eric and Phan. That was a great session. And thanks everyone for listening. Hope you stay tuned, or hope you check out the recording, and stay tuned for our next Tech Talk, hopefully in a few weeks. All right, everyone. Take care. Have a great day.
Thank you, everyone.
Thank you.
Bye.